Last time when we left off, we made this where we kill particles when they go outside a certain box-sized shape, which is quite fun and quite nice. Now, today, we're going to take that to the next level and we're going to use that death information for some new stuff. We've been working in effectively only emitters up until this point because for the most part, that's going to be where you spend your time, is making emitters that look good and then eventually combining them together. But what we're going to be doing today is only possible inside of a system, because you're going to be linking one emitter to another based on events. So let's make a system. We have this death emitter. Let's make a system out of that. And we can, if we just real quick apply the changes here, the system will reflect that. We now have this system that has like this infinitely spawning like vortex of particles, which is quite nice. A lot of particles are also dying. So let's do something with that, right? I want to add a emitter here, and we're going to be adding, it doesn't actually matter what we add, to be honest with you. So let's just add an empty emitter. We're going to be setting up our own particles for this. We don't need to put in an emitter update to spawn particles. The only thing that we really need to do for that is just, we can spawn particles real quick just to see what the particles look like when we spawn them in. Because they are going to be looking like this, which is maybe not exactly what we want. So just for the sake of showing things happening, when the particle spawns, we're going to set the color, which actually we can just do an initialized particle, now that I think about it. So particle color, we set to just like a bright red. And maybe we set the particle size to something a little bit lower. Maybe random uniform would be better. That would probably be a good particle size. So now we can get rid of the spawn rate because we're not going to be spawning them in emitter update. We're going to be spawning them based on an event. And that event is when a particle in this emitter dies. So let's add that. In our particle update here, we can generate some events, either collision, death, or location events. We're going to be talking about death events first because that's how we started this video, how we left off last time. I'm also going to show you some collision and some location events and how you can use those. But for now, let's just go for a death event. So whenever something dies, it's going to be sending out an event now. You do want to make sure that the death event happens after you kill the particles. Otherwise, you're going to check for the particles that have died in this update loop, see nothing has died, and move on and then kill the particles. So you want to kill the particles and then have the death event check. You'll also note that your compilation fails. You won't be having any particles anymore. Just click on the node as a whole, and we're going to go over here to this little tick box here, requires persistent IDs. You want the IDs of every particle to be persistent, since now it actually matters which particle is which on every frame, because they're going to be sending out events. For death events, that only happens once when they die, but specifically for things like collision and especially location events, it's very important that the system can keep track of every individual particle consistently. Which also will mean that our sim targets is limited to CPU sims. This is the other huge issue that I didn't actually talk about in the CPU GPU video because I knew I was going to make this as a separate video, and that is GPU particles, because they're just rendering pixels to your screen. They're not actually physically present in the world. There's no actual logic happening behind them. They cannot communicate with each other in this way. So if you want to set up particle events, which for a lot of like interactive and fun looking particle systems, you will want some of that probably. You are limited to CPU only emitters, which is a little bit too bad. So let's set requires persistent ID to true, and our particles are back. So now on our new emitter that we have over here, we can set up a new stage for an event handler. So we need something to handle the events, to receive the events, to do something with them. So this event handler we can assign to an event, and it can be assigned to any event on any emitter in your system. In this case, we only have the one, that being the death event of our death particle emitter. So let's assign it to that. And we want to execute this on all the spawned particles. This will be relevant because if we set this to every particle, our event handler is going to also be working on any particle that we spawn in through the normal means, but we're not going to be doing that. If you do want that to be the case, I guess you can set it to every particle. Most of the time when you set up something like this, the second emitter is only ever going to be used to spawn in particles in a response to an event. So in that case, you want to set it to being spawned particles. Now, the maximum amount of events per frame is there to limit the amount of stuff that can happen in a single frame. If you have like 1,000 particles die in one frame, you maybe don't want to have 1,000 responses to that from this emitter. So if you set this to a maximum of like 15, every frame, even if 100,000 particles were to die, which you're not going to be simulating 100,000 particles because, again, we're limited to the CPU, only 15 of those will actually be picked up by this event. If you set this to 0, it's unlimited. Then we have the spawn number. That is the amount of particles that get spawned in response to the event. So for now, let's set this to like 15, which can be quite a lot. And we can already see that it's spawning in a particle right in the middle here. This particle over here, this red and orange one, is being spawned in response to all of those death events. But it's being spawned at the exact center because we're never specifying where it should be spawned. And for that, we can add in the event handler stage, we can receive a death event. And this will, as you imagine, spawn particles in at the location of the actual death event. So we've got the position here, we've got the velocity, we have the acceleration, the random number float, like all of the information from the particle that died is getting put through to the new particle. So if we set the velocity to being true, that's a very high number, let's maybe just say 2, this should then inherit the velocity with 2 times the speed. Of course, for that we do need a solve forces and velocity, but now anytime a particle dies, it's going to spawn 15 more particles that get shot out at twice the speed of the initial particle, which is a little much. Of course, then in particle spawn, we can also add our own velocity on top of that. So instead of inheriting the velocity, maybe we don't want to actually do that, right? Again, they're just going to be sticking around, but now they're also moving upward a little bit because when they get spawned in, they still get their own velocity. So we can just set this to a random range vector. And let's set this to like 500. And now we can see it kind of, well, it's only spawning in this direction because they're spawning from 0 to 1. So right now, this is kind of just like exploding all over the place anytime a particle dies. Now, these are a lot of particles for a CPU, so probably don't fully do this. But let's keep with applying this, and then what we can do is, instead of just adding velocity like this. Now, with those two combined, of course, we have our receive velocity that is going to just put through at about 2 times the rate that the original particle was moving at. And then we can add a velocity to that, which we can, I just made a new one real quick just because. We can do a random vector in a certain scale as well. So if we set this to like 500 again, it's going to be, maybe 500 is too much. Let's set this to like 3. Or 30. 30 is pretty good. So now, anytime we have a particle die, it spawns in 15 new particles that move in the general direction that that particle was moving, but then also get a little bit of randomness added to themselves, creating this kind of like firework particle kind of look. Now, I think that these do live for way too long. So let's set them to a lifetime of between like 0.5 and 0.12, maybe. And then also add in a little bit of drag to them. And now we're spawning in stuff in response to a particle death. Now, I did prepare something that goes like a couple of steps deeper than this, just to show you how ridiculous we can make this. And that is, I believe, this one, right? So what I'm doing here is I'm spawning in particles. The moment they reach this first sphere, they die. So I think this sphere is just like an emitter that emits one mesh. Then we have this particle event here, which has a kill particles in volume. Outside of a 100 unit big sphere, they die and spawn in a bunch of new particles, which also generate death events when they die, when they go outside of a sphere with a radius of 250, which then is picked up with this particle emitter, which does the exact same thing, except that it generates death events at 500 units, and so on and so forth. Now, your CPU doesn't like this. Don't do too much of this. This is just putting things to their absolute max just to show you that you can do this if you want to. But like putting 20 of these into your level is probably going to tank your frame rate because your CPU, again, does not like it. I'm just going to put this into the level real quick and you can immediately see my frame rate did not like that. Like I'll show you, I'm at about 80 frames per second right now. If I just copy this over a handful of times, I can see every time I copy it over, my frame rate absolutely tanks. Then when the particles are done emitting, of course, there's no problem because there's no more particles. But if I now select all of these, and this might actually crash my engine, so I'm going to save everything, and I auto-activate all of them off and then all of them on, my frame rate is, just by emitting like 5 of those particle systems, dipped to like 20 frames per second. And that's because it's all CPU bound and it's spawning in potentially like tens of thousands of particles, because what you need to understand is I also used the value 15 for this one, right? So initially my spawn burst here spawns in, let's see, I think it's like 100 particles. Then at this point, for every one of those 100 particles that dies, it spawns in another 15. Meaning that now we are working with 1500 particles, which is reasonable, that's workable. Then we multiply it by 15 again, meaning that we're in the neighborhood of like 22,000 particles at this point. Then we do that one last extra time. For every one of those 22,000 particles, we're spawning in another 15 when they die. Meaning that we're now up to in the neighborhood of 300,000 particles per system. CPU doesn't like that. I had 5 systems, which meant that we're probably simulating about 1.5 million particles there. Frankly, the fact that it didn't dip below 20 frames per second is a miracle. Anyway, those are the death events. Very fun to play with. I do want to show you the collision events as well. I'm not going to go as in depth about them because they work pretty much the exact same. So I have set up some collisions to begin with here. So we've got our particle, which is just a burst, and then we have on a collision event, so we have got generate collision event, which again, important to put that after the collision in the particle update. And then this thing just takes in that collision event, and we have a receive collision event, which just applies the position, and it gets in the collision normal. And it uses that, in this case, to be able to have the particles boost in the opposite direction of whatever surface they just hit. And then we've got a bunch of stuff. It's just a directional burst system that I used for this. And for this, the particles that it spawns in are blue on every collision. So if we just, instead of doing this as spawn burst instantaneous, what I'm actually going to do is I'm going to set this as a spawn rate so that you can see it a little bit better. And we're going to be spawning like, I don't know, 50 particles per second. That seems pretty good. So you can see now, whenever one of these particles hits the ground, they just bounce around and they start producing other particles. There is one little issue that I didn't take into account here, and that is that this is now infinitely looping, and apparently we also need to set the responding emitter to infinitely looping, and now it will infinitely keep doing this. So we've now got like a raining effect that has like little splatters going on when it hit the ground, which combining this with a kill particle really is a decent way for a very localized version of having little rain droplets splatter around. Why do I say it's very localized? Because again, it's a CPU limited. You can't make a giant system with a lot, like thousands upon thousands of raindrops, all generate their own little things when they hit the ground, because it's going to kill your frame rate. But if you're making something that is cinematic and you're just rendering it, you can just do this because performance suddenly isn't that big of a deal anymore. Or if you know that it's going to be in a very specific small area and it's not going to be spawning too many particles, you can also get away with this. And this is a very accurate way of making sure that your like rain responses actually fit with whatever your rain particles themselves are doing, which is quite neat. And then the last one, I want to talk a little bit more about that, because that is this system here. You might be thinking, what even am I looking at? You are looking at position events. So much like a death event, sends an event when a particle dies. And I should clarify, it only sends an event when a particle is actively killed. When it just reaches the end of its lifetime, there's no death event that gets set. It only does events when particles are explicitly killed. Collision events, just send an event whenever a particle collides with something, if it has collision. A location event just sends through the location of your particle every single frame. So we have this generate location event, and here we can set the send rate. So if you set this to 0, again, it's just going to do it every single frame. If I set this to, for instance, 5, you can see it's a lot more choppy because it's only sending this 5 times per second. So this is kind of the frame rate of whatever your responding emitter is going to be doing. 30, for all intents and purposes, is well and good enough. Then the location event itself, of course, has the position and then a bunch of other stuff that it can just take into use if you want to, like the age of the particle, the velocity of the particle, whatever. For the sake of this system that I have over here, if I just add in a sprite renderer real quick, you can see that it's just adding a new sprites every single frame in the location that this system has its sprites in. So these sprites are moving in this way, right? Say, quite fun little way for the particles to be moving. This system is just adding particles every frame to the position of every particle in this. But since they're all individual emitters, if we do a ribbon renderer, they don't all get linked together. What happens is we get a ribbon that follows the path of every one of the particles in this emitter. If I just put in a ribbon renderer in here, it's going to be instead connecting all of the particles in this system, and that, or in this emitter rather, and that creates this weird ass drunk looking spider web. But instead, since every single particle in this emitter gets an emitter of its own, we can then start doing an effect like this, which is really, really quite useful. Again, I think I like the death and the collision ones more because they end up feeling more satisfying in a lot of ways, because usually you use that for kind of like a firework effect, right? When something dies, it explodes into more separate, smaller particles. When something bounces against a floor or a wall, it creates some sparks. Those are like the very fancy, satisfying things. I think location events are probably some of the more important ones instead. There's not particularly anything satisfying about being able to render a ribbon per particle in your emitter, but it is very, very useful to be able to do things like this. Now, we can also do slightly different stuff with this. We can also say, actually, I do want to have like a sprite renderer in this, and when I initialize the particle, I want to set the particle size to something uniform, something a little bit smaller than this. So maybe let's say like 5, and I want the velocity on startup, we then need to like fix extrude. I want the velocity to be this, and now we have like this happening where particles spawn in the location of wherever particles exist in this emitter, and they start going. And of course, I wouldn't be me if I wouldn't be adding some randomness to this. So let's add a random range float between 1 and 4. And now we get this, which already looks a lot more like visually interesting and intense, and there's a lot of stuff that you can do with this. So it's not only for just adding ribbons to particles, it's very useful for that, but you can also like create particles that kind of act as the origin point for an entirely separate emitter, and that creates a system like this. So now we're starting to work with how particle emitters can really work together aside from just existing in the same system to make something that individual emitters just simply couldn't do. Now, with all that, I think we are kind of at the end of this particle series. We could go on for a lot longer. I could show you, oh, and this is a fun thing that I once did, and this is a fun thing that you can do. But at some point, I think we've now covered the most important basics, and you can just start playing with things, discovering things one step at a time. And with this basic knowledge, it is now actually useful to go up on YouTube and look up specific like feature tutorials, meaning specifically, I want to make this thing. and watch somebody make that thing, and you'll actually understand what is going on a little bit more. So I think that is, for now, the most logical next step to do to get better at particles for you, is to just go ahead and make some stuff. Then at some point in the future, I'll probably get around to making an intermediate particle course, in which we'll probably talk a little bit more about making your own modules and scripts. But for now, don't worry about that, just go out and learn. And for the full course, if you're watching this in the future, it should be all up on the YouTube channel already. But if you're watching this shortly after it was uploaded, there will be a link down below in the description to the Patreon where you can find the full course. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. A huge thank you to my Cave Student tier supporters, Earl Monseval Erno, and my Cave Digger tier supporters, Sergey Thomas,